Hello everyone, today we'll see Leetcode problem number 49, which is the group anagram. So let's read the problem statement. So here we have given one input string array. We have to group the anagram together and you can return the answer in any order. So what does it mean by anagram? An anagram is a word or phrase formed by rearranging the letter of a different word or phrase, typically using all the original letters exactly once. So basically in input, you will given one input string array and you have to put all string together if they belong to the same group, which means the same anagram. So anagram is nothing. Let's suppose this is two string s1 and s2. Let's suppose the string are eat and ate. Okay. So I can say like both belong to the same anagram if somehow I can rearrange the ate and turn it into eat or vice versa. So I can say both belong to the same anagram. So if you see this example here, you can see that NAT and TAN. If I rearrange NAT, I can form TAN or vice versa. So I put it both the string into the same group. Similarly, you can see here ATE, EAT and TEA all are belong to the same anagram. So I hope you guys you have cleared the problem statement. So let's suppose this is the input string array and this is the EAT and TEA. So here we can see that EAT, TEA and ATE, these three strings belong to the same anagram. So what if you sort it? So you can find out after sorting EAT will be AET. After sorting TEE also will be AET, and after sorting ATE also it will be AET. So you got the intuition. Similarly, if you try with TAN, so after sorting TAN it will be ANT, and if you pick the NAT, after sorting this will also become ANT. So let's suppose you start iterating from here and you will get that EAT. So after sorting whatever the string will be, I can find out that they belong to the same anagram or not. Let's suppose I start with EAT. I have no bucket, so I'll create one bucket and I put the bucket name after sorting whatever the string I'll get. So let's suppose after sorting EAT will be AET. So I'll put this AET as the bucket name and put the EAT inside it. Okay, and I'll pick the second element now, which is TEA, and I'll check like what is the string after sorting the TEA. So it is also AET. So I'll put this word also into the same bucket, which is TEA. Now I'll pick the third word, which is TAN. So after sorting TAN, it will be ANT, and this bucket is not exist. So I'll create a new bucket here, and I'll put the TAN inside this new bucket. Then I'll pick the fourth string, which is ATE. So after sorting ATE, that will also become AET. So I'll put this ATE also into the first bucket. Now the next word is NAT. So after sorting NAT, that will become ANT. So I'll put this NAT also into the bucket 2. And the final word is BAT. So after sorting BAT, it will be ABT. So there is no bucket here. So we'll create a new bucket ABT and you will put this string into the new bucket. So I hope you got the intuition behind this solution. Okay, but before moving to the code, let me share you one more thing, that actually we don't need to sort this entire string, and instead what we can do, so I can create an hash of particular one string. Okay, so let's start with this particular string here, and this time we are not doing sorting, but this time we are creating array, and then this array is nothing, this is a recurrence array actually. So we'll capture that how many time we have get a, how many time we got b, and then we are just noticing it down into the integer array. So let's suppose these are the indexes, which is from z, and here also these are the indexes till z. I can tell you like how we can turn the character into indexes, so that we'll see into the code, but let's focus now on this particular approach. So we'll start iterating particular this string. So first character is A. So we'll update this A. So initially all characters are initialized by 0. Okay. So you will update this A by 1 because we got one A here. So we'll update this 0 to 1 and then we'll see the B here. So again we'll increment 0 to 1 and we'll get again A. So that means A is already 1. So we'll increment it. So it will become 2 now. Then you will see the fourth character which is C here. So again you will update the C. Then you will get the B. So B is already 1. So you will change it from 1 to 2 now. And the last one is A. So A is actually already 2 here. So you'll increment it and then will become 3 here. So now what we can do, you can see like these are the recurrence we found. So what we can do, we can create an hash. We can start iterating from this index by index and let's put the counter against the character. So it will become A3, B2, C1. Okay. So you will get this particular hash here. So this is not we are doing for shrinking the size of the string. Although we are doing the shrink, but that will not always the case because let's suppose we have given lot of unique characters. So in that scenario, this will not be shrink. That will become more longer. Okay, but we are not focusing on to shrink the string, but instead we are focusing on this complexity part because the earlier when we are doing the sorting, it was taking n log n time. But with this approach, it will just take order of n time only. So with the long input, that will helpful. Then if you start iterating the second string, you will see like this is A here. So you'll update this A by 1, again 1, again A. So you'll replace by 2. Then you'll get B here, then C here. Then again you'll get A. So you'll update by 3. Then again you'll get B here. So you'll update by 2. Okay, so this input string is also creating the same hash. You can see like A3, B2, C1, right? Which is the same A3, B2, C1. So now we can select these are belong to the same anagram. Okay, so this is the code here. So here you can see that here I have just declared this list and here we are put at this map so that we can group all the strings here and then we are iterating this entire list of string. Then we just make it sort. So let's see the sort function here. In the sort we are actually creating that hash. So I have created this occurrence based integer array. Then we are just iterating this entire string characters. Okay, so as I mentioned like that how we can turn the characters into indexes. So this is how we can do it. So what we are doing basically, the a ASCII value is let's suppose 97 and I'm reducing minus a, so that ASCII value is also 97. So 97 minus 97, that will be 0. And because this a here it is constant, so that character is variable. So whatever the value, let's suppose it is b, so b value is 98 because all ASCII value from a to z are in sequence. Okay, so that will increase by 1 only. So but this 97 remains same as it is for all the time. So this time it will become 1, right? So this is how these indexes are generating from here. And to get the character out of the index, so we are doing the exactly reverse operation here, which is a plus I, right? And then we'll get that character and then we are appending the occurrence as well. So that's how we can create this hash here. And then we have put at this hash as a key because all the time that hash will remain same if the characters are same in both the string. Okay, then we are just checking that whether this is exist into the map or not. If it is not, then just create new linked list, and if it is already exist, then put it into the linked list of map. So that's how it is working. Okay, then finally we have put it all the value out of this map and put it into the answer. Okay, so let's run it. Okay, so it took 26 milliseconds. Now let's try the same with rs.sort. because you can see that in the constraint this string size is very less, it is just 100. If it is very low like 100, then it does not make huge difference between order of n and n log n. So here what we are doing, actually we are just iterating through this entire character array, then again we are iterating this integer occurrence array to form a new hash. Okay, if I talk about the sorting, then in the worst scenario it will have 100 characters. So if I talk about n log n complexity, that will be 100 log 100, and let's see the log value of 100. So it's 1 2 3 4 5 6. But if I talk about the loop which we are using, so actually it will additionally taking the time to create a new separate space every single time which we are creating an integer array of 26 size. Then we are iterating through the entire string with order of n. Then again we are iterating this entire integer array which will again take 26. If I talk about the iteration only to avoid this array creation time, then still it will be 126. So let's try with the sorting now. Okay, let's run it. Okay, so you can see that it performed much better than the last. Okay guys, so that's pretty much about for today's video. We'll meet in the next video. Until then, bye guys, keep up the good work, see you soon.